carrying on with our look at using the summary statistics, we are now going to have a look at the summary statistics used to calculate PMCC. Now these can be found on page 5 and page 3 in the formula booklet, and it is given like this in one straight line. Now they could give us any part of these summary statistics, and all we have to do is put them in the correct place and put them into our calculator. Again, as we did before when we were looking at the mean and standard deviation, it's a good idea to write out the formula and write out your substitution of the summary statistics into the formulas. So again, we are given these formulas in our formula booklets. So here we're trying to find the product moment correlation coefficient for the following, and we're describing the meaning of it in context. So we have a tasting panel. We're asked to assess biscuits baked from a new recipe. Each member were asked to assign a score between 0 and 100 for texture, which is our X value, and flavour, which is our Y value. And you can see here that we've been given some summary statistics. Now if we have a look at our formula, we can see that these summary statistics here, they don't appear in the last or the middle formula, they only appear in the first formula. And this is the formula that's easiest to use. So we're going to calculate R, which is our PMCC value, using SXY divided by the square root of SXX times SYY. Substituting in our values from the question, that gives us SXY, which is this value on the end here, is 1225.2 divided by the square root of SXX, which is 2354, times SYY, which is 2117.6. Then we can put this into our calculator. So fraction button, 1225.2 divided by, down to get onto the bottom of our fraction, the square root, which is shift and then the x squared button, 2354 times 2117.6. And then when we click Exit, we get our PMCC value. A good way to check that we have entered this almost correctly at least is it between -1 and 1? Remember, that's what PMCC goes between, and yes, it is. So 0.549 tells us that we have, so there exists I'd say that's moderate, it's positive, and remember that PMCC measures linear correlation between, and this was texture and flavour of the new recipe biscuits. Moving on to the second example. Here we have the following summary statistics are for a level of sales for 10 models of pen sold by a company. X represents the price of the pen and Y indicates the number of hundreds sold. So we have our price and the number of hundreds sold, and we're trying to calculate the PMCC value and interpret it in context. So here we have, remember this symbol here means sum, add up, okay? So if we have a look back at the top, these formulas appear in this end one here, okay? Here we have the X minus X bars. We don't have those given to us though, so it's going to be this formula here that we use, which is the last one. So that means that we're using the sum of XY minus the sum of X times the sum of Y over N divided by the square root of the sum of x squared minus, in a bracket, the sum of x, close bracket, all squared over n, close bracket, open bracket, the sum of y squared minus, open bracket, the sum of y squared divided by n, close bracket. So we need to know n. Well, we can tell from the question here we were looking at 10 models. So in this case, our n is 10. So we're now going to substitute in our values. Again, do write down what you're putting in your calculator. So we're going to have the sum of xy, which is 2087.5, minus the sum of x, which is 140.5, times the sum of y, which is 193, divided by n, which is 10, all divided by the square root of the sum of x squared, so that's 2723.75, minus the sum of x all squared, so that's the 140.5 squared over 10, close bracket, times the sum of y squared, which is 4489, minus the sum of y, which is 193 squared over 10, close bracket. So now we need to put this into our calculator. So fraction button, 2087.5 minus fraction button again, 140.5 times 193 over 10, down to get onto the bottom of the other fraction, square root, open bracket, 2723.75 minus fraction 140.5 squared onto the bottom, divided by 10, close bracket, times, open bracket, 4489 minus fraction 193 squared, down to get onto the bottom, over 10, close bracket. And it's very important that you do all of that exactly. If you miss out an open or a close bracket, it'll give you the wrong value, or it'll just say that the calculator is unable to calculate it. So then when we click exit, we get minus 0.825. So that means that this time we have strong negative linear correlation between, and this time it's the price of the pen and number of hundreds sold. So I'd now like you to pause the video and give the Now You Try question a go. Okay, so hopefully you paused the video and gave the Now You Try a go. So this time we have a group of 12 children who participated in a psychological study designed to assess the relationship, if any, between age and total sleep time. And then we have our summary statistics here. So we've got, so the average total sleep time recording was taken for each child on 5 consecutive nights and then averaged. And then we have this summary statistics here. So our N is 12 and all the other information is given to us in the question. So again, we're going to be using the sum of xy minus the sum of x times the sum of y over n, all divided by the square root of the sum of x squared minus the sum of x all squared divided by n times the sum of y squared divided by, minus the sum of y squared over n. So then when we substitute in our values, we should have this here in the green. And when we put that into our calculator, we should end up with minus 0.481. So this suggests a weak or moderate, just about, negative linear correlation between the age and the average total sleep time. And then for the second Now You Try question, we have the following summary statistics are for the annual income per head, X in US dollars, and the infant mortality rate, Y per 1,000 live births of a sample of 11 countries. However, this time we've been given the SXX, XYY and SXY summary statistics, so we're not actually going to have to use that 11 countries. So again, this time we're using the R equals SXY divided by the square root of SXX times SYY, which when we put in our values here from the question, we end up with minus 0.739, which means we have a moderate to strong, bit weak on the strong side, definitely moderate, negative linear correlation between the annual income per head in US dollars and infant mortality rate per 1,000 live births. Now, this is quite important that we are writing down the values, but as you can see, it takes quite a while to write them down, especially if we're only given the summation ones as you did in part 1. That can take quite a while. There's quite a lot of numbers and it's easy to type a value in wrong. Remember that the new A-level statistics is meant to be more about your interpretation of values than it is meant to be about you calculating values. So it's very rare that it actually comes up that they ask you to calculate the PMCC using summary statistics, but it can still come up. Next time we're going to have a look at how we find the least squares regression line using summary statistics. Thank you very much for listening.